2-pole AFCI would not have prevented the fire in the scenario described. AFCIs are designed to detect imbalances in current flow between the hot and neutral conductors, which is a characteristic of arcing faults. In the case of the furnace circuit, the arcing fault occurred on the neutral conductor, so a 2-pole AFCI would not have detected it. A main AFCI would also not have prevented the fire. Main AFCIs are designed to protect against arcing faults in the main feeder conductors, but the arcing fault in this case occurred on a branch circuit. The National Electrical Code, or NEC, does not require AFCIs on 240-volt circuits, such as the furnace circuit in your example. The NEC only requires AFCIs on 120-volt, 15 and 20 ampere branch circuits. The best way to prevent fires caused by arcing faults is to use properly installed and maintained electrical equipment. This includes using the correct type of wiring for the application, avoiding overloading circuits, and having electrical wiring inspected regularly by a qualified electrician. Expanding on that, to understand why a 2-pole AFCI or a main AFCI wouldn't necessarily prevent the described fire, it's important to delve deeper into the function of AFCIs and the specific scenario presented. Firstly, let's clarify what an AFCI is and how it works. An AFCI, or arc fault circuit interrupter, is a safety device designed to detect and respond to dangerous electrical arcs in a circuit. These arcs can occur for various reasons, such as damaged wiring, loose connections, or insulation breakdown. AFCIs are designed to trip a circuit breaker when they detect an arcing fault, thereby cutting off the electricity and reducing the risk of fire. There are primarily two types of AFCIs: branch or combination AFCIs and outlet branch circuit AFCIs. Branch or combination AFCIs provide protection against both series and parallel arcs. Series arcs occur when there is a break in a single wire, while parallel arcs occur between two wires, such as a hot and neutral wire. Outlet branch circuit AFCIs, or AFCIs, are installed at the outlet and provide protection against series arcs downstream of the outlet and parallel arcs within the outlet itself. The key to understanding why a 2-pole AFCI wouldn't have prevented the fire lies in the nature of the fault described. The scenario involves a furnace circuit wired with 6/3 Nm cable being pierced by an air conditioning technician's self-tapping screw. This resulted in a fire starting above a hall closet between two bedrooms. The crucial detail is that the arcing fault occurred on the neutral conductor. AFCIs, in general, are designed to detect imbalances in current flow between the hot, or ungrounded, conductor and the neutral, or grounded, conductor. They work by monitoring the current flowing through these conductors. Under normal conditions, the current flowing through the hot wire should be equal to the current flowing back through the neutral wire. If an arcing fault occurs, it creates a sudden and erratic change in the current flow, which the AFCI detects and responds to by tripping the circuit. However, if the arcing fault occurs solely on the neutral conductor, without involving a corresponding imbalance on the hot conductor, a standard AFCI may not detect it. This is because the AFCI is primarily looking for differences in current between the hot and neutral wires. A 2-pole AFCI, while designed to protect 240-volt circuits, still operates on the same principle of detecting imbalances between the hot and neutral conductors. It's essentially two single-pole AFCIs combined into one unit, providing protection for both legs of a 240-volt circuit. Therefore, if the arcing fault is isolated to the neutral conductor, a 2-pole AFCI is unlikely to detect it. Similarly, a main AFCI wouldn't have prevented the fire because it's designed to protect the main feeder conductors entering the electrical panel. These conductors carry the entire load for the house. A main AFCI would detect arcing faults occurring in these main feeder conductors, protecting the entire electrical system from potential fires originating from the main panel. However, the fire in this scenario originated on a branch circuit, specifically the furnace circuit. The main AFCI is not designed to monitor individual branch circuits for arcing faults. Its focus is on the main feeders, so it wouldn't have been able to detect the problem on the furnace circuit. It is important to note that the NEC, or National Electrical Code, provides specific requirements for AFCI protection. Currently, the NEC generally requires AFCIs on 120-volt, 15 and 20 ampere branch circuits that supply certain locations in a dwelling, such as bedrooms, living rooms, and hallways. These requirements are intended to provide enhanced protection against arcing faults in areas where people are most likely to be present and potentially vulnerable to fire hazards. However, the NEC doesn't generally require AFCIs on 240-volt circuits, such as the furnace circuit in the described scenario. This is because 240-volt circuits typically serve larger appliances with more robust wiring, which are considered less susceptible to arcing faults. This does not mean that 240-volt circuits are immune to arcing faults, as demonstrated by the described fire incident. It simply reflects the NEC prioritization of AFCI protection for the most common and vulnerable circuits in a dwelling. To prevent fires caused by arcing faults, several measures can be taken. Firstly, use properly installed and maintained electrical equipment. This includes using the correct type of wiring for the specific application, ensuring that all connections are tight and secure, and protecting wiring from physical damage. Secondly, avoid overloading circuits. Overloading a circuit can cause the wiring to overheat, which can lead to insulation breakdown and arcing faults. Follow the ampacity ratings of the wiring and circuit breakers, and avoid plugging too many appliances into a single circuit. Thirdly, have electrical wiring inspected regularly by a qualified electrician. A qualified electrician can identify potential hazards such as damaged wiring, loose connections, or overloaded circuits, and take corrective action before they lead to a fire. Furthermore, consider using additional safety devices such as ground fault circuit interrupters or GFCIs in areas where electrical hazards are more likely, such as bathrooms and kitchens. GFCIs are designed to protect against electrical shock by detecting small imbalances in current flow and tripping the circuit. While they don't specifically protect against arcing faults, they can provide an additional layer of safety. In the described scenario, the fire was caused by a self-tapping screw piercing the neutral conductor of the furnace circuit. This highlights the importance of protecting wiring from physical damage. When running electrical wiring, it's crucial to avoid areas where it could be easily damaged by screws, nails, or other objects. Use appropriate methods to protect wiring, such as running it through conduit or using nail plates to prevent screws from penetrating the wires. In conclusion, a two-pole AFCI or a main AFCI wouldn't have prevented the fire in the described scenario because the arcing fault occurred on the neutral conductor of a branch circuit, and these AFCIs are not designed to specifically detect such faults. The best way to prevent fires caused by arcing faults is to use properly installed and maintained electrical equipment, avoid overloading circuits, and have electrical wiring inspected regularly by a qualified electrician. Additionally, consider using other safety devices, such as GFCIs, to provide an extra layer of protection. The incident also highlights the importance of protecting wiring from physical damage. It's important to emphasize that electrical safety is a shared responsibility. Homeowners should be aware of potential electrical hazards and take steps to prevent them. Qualified electricians should be consulted for any electrical work, and regular inspections should be performed to ensure that the electrical system is in good working order. By taking these precautions, we can significantly reduce the risk of electrical fires and protect lives and property. Also, it is worth mentioning that electrical codes and standards are constantly evolving. The NEC is updated every 3 years to reflect new technologies and best practices. It's important to stay informed about the latest requirements and recommendations to ensure that electrical systems are installed and maintained safely. Furthermore, manufacturers are continuously developing new and improved safety devices such as AFCIs and GFCIs. These devices are becoming more sophisticated and effective at detecting and preventing electrical hazards. It's important to research and consider these new technologies when upgrading or installing electrical systems. Electrical safety is not a static concept. It requires ongoing vigilance, education, and a commitment to following best practices. By working together, homeowners, electricians, and manufacturers can create safer electrical environments and prevent electrical fires. The fact that the fault occurred on the neutral conductor highlights a specific area of concern in electrical safety. While AFCIs are primarily designed to detect imbalances between the hot and neutral conductors, faults in the neutral conductor can also be dangerous and lead to fires. In some cases, a fault in the neutral conductor can cause the neutral wire to become energized, which can create a shock hazard. It can also disrupt the proper operation of electrical equipment. To address this concern, some manufacturers are developing AFCIs that are specifically designed to detect faults on the neutral conductor. These AFCIs use advanced sensing technologies to monitor the neutral wire for abnormal conditions, such as excessive current or voltage. When a fault is detected, the AFCI trips a circuit, cutting off the electricity and preventing a potential hazard. These neutral fault detecting AFCIs are not yet widely required by the NEC, but they represent a promising advancement in electrical safety technology. As they become more readily available and affordable, they may become a more common feature in residential and commercial electrical systems. In addition to AFCIs and GFCIs, surge protective devices, or SPDs, can also play a role in preventing electrical fires. SPD are designed to protect electrical equipment from voltage surges, which can be caused by lightning strikes, power outages, or other electrical disturbances. Voltage surges can damage electrical equipment and wiring, which can increase the risk of arcing faults and fires. SPD work by diverting excess voltage away from sensitive electrical equipment, protecting it from damage. They are typically installed at the main electrical panel and at individual outlets. While SPD don't directly prevent arcing faults, they can help to protect electrical equipment and wiring from damage, which can reduce the risk of fires. In conclusion, a comprehensive approach to electrical safety involves using a combination of safety devices, such as AFCIs, GFCIs, and SPD, as well as following best practices for electrical installation and maintenance. By taking these precautions, we can significantly reduce the risk of electrical fires and protect lives and property. It is important to remember that electrical work can be dangerous and should only be performed by qualified professionals. If you are not comfortable working with electricity, always hire a licensed electrician to perform any electrical repairs or installations. In addition to the technical aspects of electrical safety, it is also important to consider the human factor. Many electrical fires are caused by human error, such as improper wiring, overloaded circuits, or damaged electrical equipment. To prevent these types of fires, it is important to educate people about electrical safety and to encourage them to take precautions when working with electricity. This includes teaching children about the dangers of electricity and how to avoid electrical hazards. It also includes providing adults with the information they need to safely use and maintain electrical equipment. By raising awareness about electrical safety and promoting responsible behavior, we can help to prevent electrical fires and save lives.